Hi everybody. In this video we will be looking at the different circuits that compose the ALU, so the arithmetic and logic unit that is a main component of the SCOT CPU. In this demo app we have here today, we will go through the different circuits of the ALU, its different operations if you want, and we will use the board to interact with it. So the way this application is set up is you will have this byte here, which will be the A input to the ALU. This second byte here on the left will be the B input. As before, we will be toggling through the different modes with these up and down buttons. Excuse me. And we will use the switches to put different values on each of the inputs. The LEDs here, the LEDs on the right part, are used to show the result, so what's coming out of the ALU. In this demonstration program of the ALU, there is no accumulator, there is no temporary register, it's just straight ALU circuit. These LEDs here will use to indicate different signals. So the first 4 LEDs here will be the flags that come out of the ALU. So the carryout flag, the A larger flag, the equal flag, and the 0 flag. And these 3 LEDs here will indicate basically the operation mode of the ALU. So now we can see that it's all up. It's at 0 because 0, when you send 0 to the ALU decoder, it is equivalent to selecting the adder. So I have put 2 values here on different buses. In this case, I have the value 20, so 16 plus 4. And here I have the value 22, so 16 plus 4 plus 2. By default, the ALU is in adder mode. So we can see here that the result, the sum, if you want, of 20 and 22 is 42. So in binary 10, 10, 10, as indicated by the LEDs. If we move to the next mode, we are using the shift right circuit. So we can see here for the switches that are up, namely this one, the LED next to it to the right is the one that becomes illuminated. And we can see here that these 3 bits, we are using operation 1 of the ALU. Now if I turn on this bit here, we will see that the carryout bit is turning on because we are shifting right this bit, which goes to the carryout. So shift left, very similar. So you have the bits shifted in the other direction. If we go to the knotter, we see that all the lights turn on except the ones where we have the bit for 16 and for 4, the ones that are on. So that's what we expect from the knotter circuit. Here we move on to the ANDer. So we have 22 and 20, so bits that are on in both circuits are the 16 and the 4 bits once again. In the OR now we will have basically the inverse, so the other value, because all the bits that are on in this A byte are also on in the B byte. And finally we get to the last mode, which is the XOR, exclusive OR. So in this case we only have 1 LED on, which corresponds to bit 2. Excuse me, bit 1, bit 0, bit 1, because it's the only digit that is on only in one of the two inputs. So we can see that the ALU in this case is behaving as expected. So far we have seen a bunch of different circuits in the previous video, all the basic gates, a lot of the decoders, enablers, the different parts that will be used later on. Here we have pretty much a complete ALU. And the next step is going to be to start moving towards what is called sequential circuits. So we're talking about memory, registers, the RAM, and also the clock and the stepper. And we will see in the next demo that this is where things start to be a bit more difficult. We will also see right in the next video, I'll do a bit of a code review of the circuits for the ALU. So that's going to be coming up very shortly, so stay tuned.